My name is Chris Cutshaw. I am a stewardship coordinator for Friends of Nevada Wilderness. So typically I would actually be out in the field right now with a bunch of volunteers and participants for the in-person Black Rock Rendezvous. But since that's not able to happen this year, I am helping to run the virtual version of it. And so we are lucky enough tonight to have a couple folks from the Fleischmann Planetarium. We have Paul Mcfarlane, who is the director of the Fleischmann Planetarium. He is also a UNR graduate. His bio also has a bunch of awards and recognitions that he's gotten, but I'm not going to go through that right now. You can just know he's got a lot of them. He studied astronomy and astrophysics with the Reno's Department of Physics, doing coursework with the McLean Observatory telescopes down on the Redfield campus. Paul also trained at Johnson and Kennedy Space Centers with aerospace and NASA experts in astronomy, engineering, and planetary science. He was serving as the lead flight director for the Challenger Learning Center in Northern Nevada. Is it Commander Mcfarlane? Is that what we call you?
Sure, that works if you'd like.
Commander Mcfarlane. Previously, Paul taught K through 12 students for more than 25 years in Washoe County. A bunch more recognition there. He was great. And he did want me to say, in case anyone from NASA is tuning in, that he would be willing to go to the moon if you are looking for someone to man that mission.
Me too.
So NASA folks, we've got a couple astronauts ready for you. I'll throw my hat in the ring on that one too. And then we've got Seth Nudie. Seth, go ahead and wave to the camera. Say hi. So Seth was born and raised in rural Nevada. He graduated from the University of Nevada, Reno, studied geological engineering. He did a really cool internship with NASA's Jet Propulsion Laboratory that involved Mars data analysis and candidate landing sites on the Martian surface. He now enjoys doing scientific outreach towards all the curious minds that come to Fleischmann Planetarium. He also likes hiking, camping, reading, and writing. But when there are in-person things, you can go and see Seth and learn about the mysteries of our universe. So really happy to have you guys here. I'm just going to hand it off to you, and I'll pop in with any questions that folks have.
Great. Thanks so much, Chris. We're excited to be here and always excited to talk about space and stars and the universe. So we've got hopefully some fun treats this evening, some things you can try out. I do see a question over there right off the bat about mentioning the SpaceX almost launch. We were excited. I know a number of us were tuned in and ready, and of course the weather caused that to have to be scrubbed, but we'll be looking forward to that on Saturday. It's an exciting era to be able to be returning to the International Space Station on American rockets, on American spacecraft, and of course the precursor to going to the moon and onto Mars. So lots of exciting possibilities here. So we're going to talk a little bit about some things that you can explore and discover, and our topic was about comets in particular. So I'm going to see if I can go ahead and share my screen here and pull up a little bit of a presentation that goes through some different things. We've got a couple video clips as well. So let's see, we'll push play here. And here's some of our team members doing what we would prefer to do is in person, of course. If we could, we would love to have you at the planetarium. We're hoping for that day to come again soon. And so we're thankful for our medical scientists who are working steadily for a vaccine and a solution to the situation. But in the meantime, we're excited to be able to do things using technology, leveraging tools like this one. And we've got some other tools that we're going to be introducing tonight that are special opportunities as we're attempting to adapt and provide more chances for people to explore space. We think we've found some cool solutions to that. So tonight we're calling it partly Comet Quest is part of it. And we're kind of introducing this idea of being members of the Star Walker Academy. When we're inside our dome, we like to take people on a guided star walk through the sky as we touch upon different topics and highlight exciting and amazing different objects in our universe. So that's kind of what we're going to try to do a little bit of tonight as well. here is the cover of Sky and Telescope magazine. The lead story is Catch a Moving Comet. And I know in some of our meetings we were talking about, oh, it's exciting prospects for May, June, July. There are several comets out there that might flare up. They might get really exciting, or they may fizzle out too. And so they can be capricious, and you never know for sure. If you attach yourself to the tail of a comet, you don't know if it's going to become spectacular or if it's going to be a fairly faint object. Right now they're fairly faint, and we were kind of joking the other night as we were practicing, might be the best place to see the comet is under your kitchen sink perhaps, but we're going to show you some tools that you can use to try to pick some out and then possibly image them as well. So if you're interested, that's the lead story for July there for Sky and Telescope, a great publication. We're going to try to do a little bit of a comet show, reaching back in time for a moment to a classroom presentation since we can't do this currently. But the topic was cooking up a comet. And the idea behind this is to illustrate what are the different components of a comet. Basically, it's been described by some astronomers as kind of a dirty snowball. And as it gets within, usually within the orbit of about Jupiter, it begins to sublimate, go straight from a solid to a gas. And that's when things get exciting, where you can potentially see the tail as it's illuminated by the sunlight, and it stretches out far away in the opposite direction of the solar wind. So this is about a little 5-minute program. If you wanted to actually replicate this, you can find some of these online and you can try this using various ingredients like dry ice. And so that's kind of what we're going to show. So we thought we'd start off with that, and then we have a little game that you can actually, a free game that you can download, which should be fun. And then we're going to look at a couple of different tools, two of which actually we just recently, we were kind of speeding to try to get available, and we'll mention what those are if you'd like to avail yourselves of those. So let me see if I can go ahead though, and we'll start with the Comet Show. And presenting today on the Comet Show, we have a very special presenter, and that is Commander Rankin from here in astronaut headquarters. Here's Commander Rankin. Welcome. Let's welcome Commander Rankin today. We also have today our special guest, also from the Challenger Center, and that is Chef Craig with us today. Here's Chef Craig. Give him a hand. All right, so we're about ready to begin. We've got our Comet cookbook here, and we're going to start looking at some of the directions. We've got our dry ice, which is really, really important. We've got some water up here. We've got 3 cups of water, but we've got a little bit of ammonia that's going to be in the comet as well. And we have, from outside on the Florence Drake playground, our very own, a little bit of sand and dust and small rocks, right? Remember we talked about it being like a dirty snowball? So it's got that little bit, those little chunks of rocks in there, which will become the meteoroids and micrometeoroids out there in space, floating around. And we've got some, a can of kind of organic material. We've got a wide mixing bowl, right? So our wide mixing bowl for putting it all together, like the solar system there. And we've got a spoon, a hammer, and we've got our insulated gloves, right? We begin to break that up into very, very small bits and pieces.
Actually, you're going to do it on the floor, so don't
You want to? Commander Rankin has some water. She has her measuring cup. She's going to pour in about 2.5 cups into our big cosmic cooking bowl here. Now we can add a little dash of sand, right? So let's take some of that sand and a little bit of it, maybe, I don't know, about 1/3 of that, you think? Add a little dash of ammonia. A little bit of ammonia.
Oh, I think I skipped over part of it there. Didn't mean to. I was clicking on a side thing there. I'll go ahead and I'll do the stop share there, but that's not what we want. Let me see if we can go back into that there. Sorry. So I'll see if I can pull that up at about the spot where we were at. If not, we'll give you kind of a preview. Let me see if I can actually do it a little bit different way. I'm going to share it this way, I think. So if I go in and do it this way, we were about where we were going to mix up the ingredients, and you'd be able to see as it began the outgassing process. So let me go ahead and see if I can jump to that spot. We always love how Zoom can be unpredictable that way, but let's see.
Comets are just as unpredictable. Don't forget that.
That's right. And whether it's going to be a good meteor shower or not, based on the little bits of rock and dust that are left behind by it as well. All right, I think we got the video back on track, so I just need to go back to the Zoom screen so that we can actually get to the feature to share that. Then I think we can scoot forward, because it was just about to get to the exciting point, and I was trying to make sure it wouldn't cut out and did just the opposite on that. But all right, here we go. So I'll skip forward to the place, all over that. And we're past that point. So I think Craig, who teaches here locally, a wonderful guy, Craig Rodrigue, he and his wife do a lot of outreach, educational outreach as well. He teaches at TMCC. She's an astrophysicist at UNR who used the Hubble Space Telescope. And so they and their children do a lot of outreach with us. So I think this is what Here we go.
Commander Rankin has some water. She has her measuring cup. She's going to pour in about 2.5 cups into our big cosmic cooking bowl here. Now we can add a little dash of sand, right? So let's take some of that sand and a little bit of it, maybe, I don't know, about a third of that we think. Add a little dash of ammonia. A little bit of ammonia. Can I smell that? I don't know if I can smell it yet. Okay. And then we've got our organic material here. I think. Yeah, let's see how much. Let's add. Oh, go ahead and just give it a good pour there. Lots of good organic material. Let's put more in there. 2.5 cups of dry ice to the mixture, stirring carefully. So here's our first cup. Whoa, okay, now our mixture is getting magical here. Listen to the bubbling gases as the comet forms. Applying the pressure of gravity. Comet Craig, we present to the world here. Look at it, you can see the rough, uneven shape. Look at the gases, the carbon dioxide gases coming out from within the ice. And as it melts, you see all the little tunnels and craters that are formed. Out for the solar wind, right? Can you feel the solar wind? This is a hairdryer, but this is going to simulate the particles flowing out from the sun like the solar wind, right? When the comet gets within the orbit of Jupiter, then we can begin to see it, and we're going to put our comet here on the overhead projector. And look at the gases coming off of it. You can see kind of the gases as they're being pushed out away from. So even if the comet's moving away from the sun, the tail will point out in front of it.
We've been in the comet experience.
And if you get into really heavy-duty comet making, you need your serious protection, the headgear.
Please hang up and try again.
Okay, so that's cooking up a comet with the different ingredients that you might use that are some of the same things that they actually use in spectrometers. You can determine what the composition of the comet is, and not that it has root beer or soda pop in it, but it has a variety of different chemicals, and those are similar to the ones that you would find. So kind of a neat experiment that you can do. we mentioned at the end, you don't want to make an ice cone out of it or something like that, snow cone out of dry ice. We did that as a separate activity with regular water ice instead of carbon dioxide ice. But kind of a fun way to learn a little bit more about it. I'll go ahead and I'll share the screen again, and we'll see if we can pop back in, not to the show, but to a different one. And I'll just show you, there's a free NASA app. It's a little program. You used to be able to get it on your iPad, but now you can get it on your computer. And here we go. We'll select that one. And it's called Comet Quest. NASA and the European Space Agency did a mission where they were sending a spacecraft to a comet, and they were going to be landing a little component. You can see that little piece that's coming off there, the fillet lander that was to land and study the comet up close. So they created a number of different educational materials, including this little game. And what we can try to do is see if we can come back to that game. You actually give it a little try, and you can play that, earn a high score, learn a little bit about what sorts of experiments they were attempting to do. So that's an option that's out there. But we thought we'd mention some tools, and especially for people that are interested in how can I do astronomy during this quarantine time while we're at home or in our backyard. And so the planetarium has been attempting to switch to kind of an online or virtual mode since we can't do our shows and workshops and weekend activities. So here's a program. We've partnered up with Celestron, which makes fantastic telescopes. There are other great telescope companies out there as well, but Celestron's been doing a lot of educational programs, and they've been working with us. And during our evening programs that we were doing, we were using Celestron telescopes, so we thought we would go ahead and continue to partner with them. And they just came out with some new technology. Now, because we can't be there doing the program for you, they in January just introduced a new technology. It's called the StarSense, and it's an app that you can get for your phone, and they give you a code when you buy one of the telescopes that allows you to actually point your telescope at a number of different objects and see those, and then hear a commentary where they actually tell you about the different things that you're seeing. And it's a really an amazing, it makes, it's like having your own private guide to space that way. So this is a little bit of a kind of a commercial about the telescope, but we have a couple of these. They've become so popular during the at-home education and quarantine times that there's actually a little bit of a delay of a couple weeks for the shipping, but we at the planetarium, because we are a nonprofit and educational program, we can order it for less than that other big online store that maybe we won't mention, which is a great resource for a lot of things, and we don't have taxes or shipping costs, so we can actually get it to you for less than Amazon or Walmart that way, and you're supporting an educational program. So I'll go ahead and show you. This is what we've been using lately for some of our education programs. Let's see.
Ready for a new kind of telescope experience? Unlock the power of your smartphone to help you navigate the night sky. Introducing StarSense Explorer by Celestron. It's fast, easy, and accurate. In minutes, you're ready to take a guided tour of the universe. First, dock your smartphone and launch the StarSense Explorer app. Unlike other astronomy apps, StarSense Explorer aligns precisely with your telescope and uses sky recognition technology to pinpoint its exact position in the night sky. Follow the simple instructions, and in seconds, the app generates a list of all the best objects currently visible in the night sky. Select an object from the list and follow the on-screen arrows to the desired object. As you move the telescope, StarSense Explorer recalibrates its position in real time. The bullseye turns green when your object is ready to view in the eyepiece. It's that simple. StarSense Explorer works anywhere in the world, no cell signal required. So whether you're in your backyard or a remote dark sky location, the universe is yours to explore.
So that did a better job. We were trying to decide, should we go ahead and set up the scope? And we actually have one of them back here that we've been using, and it really is amazingly easy to use. You pop in, just attach your cell phone to the telescope, and then you select, do I want to look at a double star like Albireo A and B? And you tap on that, and it tells you where to point. And you look in the eyepiece and you can see the two stars resolved that way, and you can see the blue and the gold. And it's funny, so that's one tool that we've been having fun experimenting with, and it really has worked tremendously. And we've used it for a list of different things that you can currently see out in the nighttime sky, so we'll be touching on some of those in a little bit. Let me go to the other tool.
Paul, if I
Sure.
could add one more thing about that telescope. for a beginner telescope, it's quite extraordinary too, in that as with most telescopes, there's a huge temptation for anybody to set up a telescope, take a while to do it, and then you want to look at an object, and then by the time you are able to look at the object, it disappears behind a building or disappears behind a tree. And what's really quite excellent about this telescope is it's simple enough and easy enough, and it's smart enough that you can actually just pick up the telescope, walk to an area where you want to look that's different than where you started, set it down, and it's already good to go. You don't have to align it again or do any of that tedious process that you did before.
It really is true. I have to say, it's been a pretty amazing little scope for us. We were trying it the other night, and we were just moving it around in the yard. We needed to look at some things, and my roof and house was in the way. So I just picked it up, plopped it down another place, and it sees the stars, kind of using the same technology that space satellites use to locate. It knows what stars it's looking at. It can identify that pattern and actually orient itself that way. So using the billion-dollar technologies that's been used on satellites, you can now adapt that and use that for your telescope as well. And it's a proprietary thing that Celestron has developed. So we're excited about that. We have 2 of those telescopes come in June. So if somebody wants to grab those, there's a link, and Chris told me that he would share that with folks if you're interested, or if you go to nevadaspacecenter.org, we have it on that page. You can click on that link as well, and that'll take you to the Fleischmann Planetarium online store. And so the nice thing about that one is you can do that without having to pay taxes or shipping costs, and then we'll come in and deliver it to your location curbside if it's in Reno Sparks in the area here. So let us know. That's one place. The other tool, in addition to that telescope, is we've been working with the folks at
Can I interrupt you for a second?
Sure, sure.
I just want to let folks know that that link is on blackrockRendezvous.org.
Awesome.
And then I will put it in the chat in just a minute. And then someone was wondering what the cost is on one of those things.
Sure. So they have different telescopes that you can get that StarSense technology on. A lot of the scopes that we use are a couple $1,000 scopes, but most people can't afford that. We can't afford that. I can't afford that myself for my family. But what they do have is they have some smaller telescopes. So they don't have as much light gathering capability, but they do have the capability to use that technology and see some amazing things. So if you're not having to gather data for a research project or something, but you're just wanting to enjoy kind of the beautiful things up there in the night sky, you can opt for some of those. This particular one that I've got behind me here is a 4-inch refractor that uses that technology where you attach the cell phone. That's a $400 or $399 telescope, but the other one that we thought would be a good introductory one, and it has high quality Celestron optics, not kind of the cheap ones you find sometimes in the department store ones. That particular one is $169, and again, no taxes. So it's a refractor. It's about a 3-inch refractor. You attach the scope to the side, you can move it around, pivot it, and you have fine controls that you can do to kind of adjust it so that it's right in the bullseye that way, and then you can take a peek. So that one's $169 and no shipping and no taxes. So we felt like that's pretty darn good, especially since most of the scopes that are out there, like I said, are a couple $1,000 scopes, but this one incorporates that technology. And it's not, like I said, it's got good coated optics. It's not a cheap telescope like a lot of the ones you find around Christmas time and stuff like that in department stores. So thanks for the question. And again, we appreciate it because a little bit of that helps to support the planetarium as well. So not saying you need to have that or have to have that telescope, but it's a great tool, and it's easy to use without having to have an engineer or a technician right by your side the whole time that you're doing it. So something to think about. The other tool that we've been working on is we partnered up with SLU, which has this remote robotic telescopes in dark sky spots around the world, including Chile, including the Canary Islands. And in fact, I just had set a mission to look at Albireo A and B, one of the really beautiful, gorgeous double stars. And I got a little phone message saying, oh, your mission to Albireo A and B, I set it up to take the images. So I may have to check on that and see if I got some good images of those 2 stars. But that's what the things you can do with this. The National Science Foundation grant allowed them to create curriculum for students And we have the ability now to offer that to planetarium members, and we're the first planetarium in the world that's partnered with them to do that. They've just offered it through the International Planetarium Society, and this is the first time we've actually shared it with anybody. So we're excited to be able to announce that partnership. So if people are interested, they can go to nevadaspacecenter.org. They can click on that link, and for $20 a year, you can control these amazing, huge telescopes, some of them like 20-inch telescopes, robotically in different spots around the world. When it's light here, it's dark in some of those places, so you can do astronomy during the daytime that way and get some gorgeous images. So, and we have an astronomy club that Seth and I are going to be working with people here locally so that we can work through different quests and missions. So that's kind of it's called SLEW, and they have these amazing telescopes. One's for looking at the sun safely, for looking at deep space, deep sky objects. And it's part of our club, our astronomy club for students of all ages, young and old, or parents and kids, grandparents and kids. You join missions, you go on quests, you use robotic telescopes, you capture images, you get to do activities and learn more about the moon or the sun or many of these other things. And you can earn digital badges with friends and fellow explorers, make posts, share your descriptions of those things. So something fun to try out while you're at home doing science from your desktop that way, and controlling some of the coolest and best telescopes in the world. So really good deal that they've made available to the planetarium, and a way for them to be able to group us so that we'd be, for example, a group of 30 of us doing some of these activities together if we wanted to, or you could do them individually and independently. So this was an image that I was able to take just the other night of the waxing crescent moon. I'm doing the Moon Quest, and I just purchased one of these $20 memberships for my daughter to be able to do that too. So she's starting on this and having some fun getting to explore and control real research quality grade equipment that way for a very inexpensive price. So that's this image of the waxing crescent moon. We were looking at the great Hercules cluster the other night, both through this telescope and through the Canary Island telescopes. The Beehive cluster, an open cluster of stars, and we'll come back to some of these objects later on if people want to ask about them, where they are, so find out some more information about them. Bodes Nebula, which is actually a galaxy in the Great Bear, Ursa Major, in the Big Dipper there, so you can take a look at that particular one. That was one that we took an image of. And then we've been looking at Leo, is something in the night skies right now, the constellation Leo, and there's a triplet of galaxies, including, I don't know if you can see my cursor on there, but a couple of these M66 and M65. And the third one is sometimes called Sarah's Galaxy, or the Hamburger Galaxy. I don't know if it looks like a hamburger edge on that way a little bit. We'll see if we can zoom in a little bit. And this was another image that we took with some of those scopes. So you get time on these telescopes. You can point them at the things that you want to do and schedule these missions to operate robotically. So that's the Hamburger Galaxy, NGC 3628 there, which is kind of fun. And then one of my favorites, an object that you can see with the naked eye, but it's just barely a point or a fuzzy, is the Andromeda Galaxy. So some fun stuff that you can do with those telescopes. But I said I would try to see if I could pull up that Comet Quest thing. So I'm going to back out of this presentation, just pull up the NASA website for a minute, which of course has tons of great resources on it. And let's see if I can do a share of that page. So I'll come over here and see if we can share the screen and zoom in on that and do a little demo of, perhaps, let's see if this one will share. So this is the website where you can get the StarSense. That's our online store for the Fleischmann Planetarium through UNR. They have the capability to be able to do that, and that's the tax-free version. This is where you would sign up. If you go to Nevada Space Center, we just posted these two things about an hour ago, the new telescope. If you want to see that again or find out more about joining that club, you can do that. But here is the free app on the NASA website, the Comet Quest. So if you click there to play, and it says, oh, I don't have the version open, the Safari version. You have to have Flash installed, and I know Mac is kind of funny about that. But if you do that, you can tap on that, and you can download Flash, and then you can run this app, and it lets you gather information about this virtual comet. And you can see as the outgassing occurs and different particles break off of it and things like that, you can gather the information, you collect it and get points and stuff like that. So I thought I'd had this open on the Safari version. Maybe I'll try that later on. But at this point, I wanted to make sure that you got to hear the really good information, which is what Seth has. So I'm going to kind of back out of things for a minute, and you can find out more about it. We talked a little bit about comets. We talked about the micrometeorites and micrometeorites and the material that's left behind when a comet sublimates and it passes through. And that's where we get these gorgeous meteor showers like the Perseid meteor shower and others. So Seth's going to take over the reins here and do a little bit more detailed kind of program, but we wanted to start off with some fun things that kids or families might think about. So I'll stop the share on that. And Seth, are you ready to take over?
Yeah, I'm ready to take over. Looks like I still, oh, there's screen share opportunities just popped up.
Perfect.
So just before I begin, I just want to kind of tell everybody a little bit about what I'm going to show you guys as some information. So with all of these comets that are coming around so far to kick off this year, and all these, since everybody's at home and looking up in the sky now that they're looking for things to do while they're at home maybe or in quarantine, and checking out all these meteor showers that are coming up too, sometimes it can be a little bit of information overload when you're looking online or watching the news and you have all these terms and all these astronomical names that are coming in. And I'm going to kind of go over a little presentation for you guys, try to help break down some of those terms so you know what we're talking about when astronomers start mentioning particular things. But then you can take this information and share it with your friends and family, and you'll sound just like the rest of the astronomers. So hope you guys enjoy it, and I'll get that pulled up here in just a second. So I got this little, all right. So here's our little slideshow I put together just for this occasion, just to kind of cover some of the information that you might find for comets, meteors, and showers. And I hope it kind of irons out some of the details that people might be curious about. So an interesting lineup so far. We've had a lot of interesting opportunities start to pop up in the beginning of this year, including Comet C2019-Y4, also known as Comet Atlas, C2020-F8, also known as Comet Swan. And while those aren't the only two big ones that are pretty popular or all over the news recently, I want to point out a third one that appears to maybe be coming up here in the recent weeks or the recent months. Hopefully we'll have a nice little fireworks show for 4th of July, as the Comet C2020 F3 Neowise is going to be coming into the inner solar system and reaching Perihelion, so that's its closest approach to the sun, around 4th of July. So hopefully that'll be a naked eye comet that we'll be able to see. Comet Atlas and Comet Swan have been rather difficult for many people to catch here in the States with naked eye astronomy, because just recently Comet Atlas began to break up into smaller pieces and started to kind of dim down a little bit. And then just recently Comet Swan did the same thing. It started to dim a little bit. So they weren't as great as we would refer to them as great comets, which are really visible, really bright, naked eye objects. But hopefully, as comets are always really finicky and unpredictable, you can never really bank too much on them. But hopefully Comet Neowise will kind of turn the tide a little bit, and we'll have some more opportunities coming up later this year. Now, comets have really... Oh, yeah.
Seth, could you tell me what perihelion was again?
Oh, I'll be covering that here in another slide.
Okay.
Yeah,
gotcha. I'll wait then.
Okay. So comets have really interesting names, all the letters and numbers, and what does it all mean? And I'll use Comet Swan as an example here. So up at the top, you've got the name there. And that letter that precedes the name usually indicates some important feature to know about the comet. As in the case for Comet Swan, it has the letter C, which means it's a non-periodic comet. So it has an orbit that takes longer than 200 years, or as other non-periodic comets, they might just altogether leave our solar system because their trajectory sends it way out into space and it might not return. And you can see there's other classifications there, other letters that indicate different kinds of objects. And one that was just added in recent years is the letter I to indicate an interstellar object, such as Oumuamua, which came to our solar system in 2017. And it's an interstellar visitor coming from another solar system that we first thought was a comet, and then we had to identify it with the letter A because we misidentified it as a comet, thought it was then just some other asteroid, and then we had to reclassify it again with a new letter I to indicate, hey, this came from someplace else. And then there's usually the year in which it was discovered, followed by a letter and a number to indicate the half month in which it was found. And if you look in that table down below, you'll see that they don't have the letter I or the letter Z. The reason why they don't have I is because it'll get confused with the number 1, so they just decided to get rid of it. But using Comet Swan as an example, it was found in the latter half of March, which you can see with the designation for F, and has the number 8 because in that time period, it was the 8th comet that was named. So comets come in swarms every year. They're just always around. We're always finding more of them as our technology gets better. And we find tons and tons of comets all the time. And then there usually ends or has its nickname with either the person that found it or the team or the scientific instrument on the particular telescope. Now, Comet Swan, the SWAN actually stands for Solar Wind Anisotropes, and it's on the SOHO Space Telescope. So it's not the name of a person or a pretty bird per se, but it's the name of the instrument that's on board that craft. So when you look up at a comet, what should you see? If you're able to go outside and take a look, and what are you going to find? And what we're talking about, I decided to throw in a little symbol here, which actually is a good demonstration of kind of the origin of the name comet, which actually means a long-haired star or a hairy star. Back in the day, before telescopes, we could only see the great comets, which were the really bright ones that were bright enough to actually make out with the naked eye. And they used to think of them as stars that just had a lot of hair around them or an atmosphere around them, and they didn't really know what they were. But recently, we were able to send a spacecraft to the Comet 67P Churyumov-Gerasimenko. I hope I said that correctly. And this is what we call the nucleus. It's actually the center of the comet. It's the solid rocky body, which isn't just rock, as we saw in Paul's little cooking up a comet little video. It's composed of a lot of rock and ice and dust, and there's a lot of debris. And really a dirty snowball is actually a really good nickname for comets because they carry a lot of material with them. And then that kind of misty area around the nucleus of the comet we call the coma. And as the Rosetta spacecraft approached this comet, we were able to see a lot of that debris start to leave the surface, leave the nucleus. And as comets will begin to leave the area of our solar system dominated by the outer planets and begin to come into the inner solar system, about where the asteroid belt or Mars are usually located, the solar wind starts to take effect and starts to blow that coma away from the comet, which is caused from this outgassing. And the outgassing, as the comet is getting closer and closer, it warms up. And all of that ice wants to completely melt, but instead of going to a liquid, it goes straight to a gas. And that's what we call sublimation. And as it nears the inner solar system, that solar wind will begin to blow that material out into space, and the solar wind creating multiple tails. It doesn't always create multiple tails, and sometimes they're pretty spectacular, sometimes they're pretty pathetic. But there's usually two tails, and one tail is the dust tail and the ion tail. The ion tail will always point directly towards the sun because the solar wind has a direct effect on it and will push that material away, and all the charged particles that are being carried by the solar wind react and create kind of an ion trail or a gas ion tail. And then the dust reflects visible light, which is sometimes really bright and sometimes has a curved streak through the sky. And the solar light and the solar radiation actually push slowly and gradually on that dust and all those little small particles and start to push them out kind of in a tweaked little orbit. And that's why one tail is usually really straight and one tail is usually really curved. And we believe that there's about two different regions in this comets come from, and we've got short period comets, which we believe to come from the Kuiper belt, which is just outside of the orbit of Neptune. And short period comets have orbits less than 200 years. And then long period comets, which have orbits greater than 200 years, which we believe to come from the Oort cloud, which is a really big bubble out there in space. And then perihelion, as Chris was mentioning earlier, perihelion is simply the closest approach that an object will make as it orbits the parent body. So in the case of a comet, it reaches perihelion when it's closest to the sun, is what we would usually be referring to. And then you'll often encounter these little mile markers when we're talking on objects in the scale of our solar system. And we use the Astronomical Unit, or the AU. And it's based on the average distance of the Earth and the sun. And as an example, the Earth is 1 AU. And Venus is around 0.7 AU because it's inside of our orbit. Mercury's even less. And the outer planets are greater than 1 because they're that many times further than the Earth. And then we have extinct comets, which is sometimes a fun one to encounter. Extinct comets are old enough that they've actually expelled all of their gas and all of their ice because either they're so old or they've passed too close to the sun too many times. And now they're just inert objects that resemble more like asteroids than they do actually comets. But after the comet kind of passes by, it leaves a huge debris field. And I'll show you guys a link here afterward to a really cool site where you can look at these meteor showers and where and why they originate the way that they do. But every once in a while, the Earth will pass through those debris fields left from comets. And that's where we get meteor showers. And the reason why they are really regular and we encounter them the same time every year is because as Earth orbits and comes around to that same point the next year, we go through that debris field once more. But then there's the 3 M's, which I'm going to talk about.
So can I ask, how does a comet differ from an asteroid? Is it a lot bigger? Is it origin or?
Primarily origin, but also its components that make it up. So a comet is going to have a lot of primitive material out in our outer solar system, a lot of ice and a lot of gas that form in that stable area out there for those ices and those gases to condense. Whereas an asteroid is typically around some of the gas giants or in the asteroid belt, are close enough to the sun generally that they've already expelled all of that material or it wasn't fitting for that material to form in the inner solar system because of the increased temperature.
Okay.
So in a general term, an asteroid is basically just the rocky lump that doesn't have any of that moisture, whereas a comet does have a lot of those, a lot of the different kinds of ice and gas that are more stable in the outer solar system. And that's why when comets begin to come in and into the solar system, they start to generate that big coma because they're starting to warm up and that material's starting to dissipate off of its surface. And then as it gets close and close, then the solar wind generates those tails as it warms up and it gets really close to the sun. And if it, just like an extinct comet, if it gets too close too often, or it's too old and it's expelled all of its ice and all of its gas, it becomes an extinct comet. It will resemble an asteroid, but technically it's still a comet. It just resembles an asteroid in the way that it won't really have those coma or the interesting tails that comets typically do.
Okay. Thanks, Seth.
Yep. And then with meteor showers, we got the three different M's that are sometimes us astronomers can be a little finicky about. We have first the meteoroid, which is the actual object that's floating around in outer space. Whether or not it's in the asteroid belt, in between all the planets, of whether or not they're microscopic or they're really big, the meteoroid is the actual object as it's floating out in space. And then as it approaches an atmosphere, such as a meteor, and it streaks through the air, that's where we get the term meteor showers. Now, meteor is actually a term to the phenomena of it entering the atmosphere. And then you have, if it survives the trip of being a meteor for that very short and brief time, if it survives the trip, it becomes a meteorite if it makes it all the way to the ground. And then despite what most people are led to believe, it's not really friction with the air that generates all of that heat and all of that light around a meteor as you see it streak through the sky, but a process called ablation. And you got to remember that these objects are traveling many thousands of kilometers an hour or kilometers a second, and they're moving super, super fast. And when they hit the atmosphere, they're basically hitting the brakes, because the atmosphere is a lot more dense than the space out beyond us. And there generates a really high pressure. All of the gas in our atmosphere is superheated because of an increased pressure just in front of it. And it creates such a high temperature and such a high pressure that as it passes over the rest of the surface of the object, it begins to vaporize some of the material actually off of the object, and that's what we call ablation. And if the object is small enough, it won't survive. But if it's large enough, it may survive that breaking period and then fall to the ground as an intact object. And just as a reference, most of the little meteors that you guys see during meteor showers are oftentimes the size of a grain of rice or no bigger than a marble. But sometimes, as you'll see on this next picture here, is what we call a fireball or a bolide. And those objects are about the size of a baseball or a softball. And they can oftentimes survive as individual chunks or pieces coming down to the ground. However, when they hit the atmosphere at those high velocities, sometimes that high pressure caused from ablation begins to actually shatter or break apart the object, and then you'll see a really cool display like you see down below. And I've been lucky enough to see at least one bolide in my observing before. Lots of little streaks, but only one that really put on an impressive display. And then sometimes you'll see little streaks left behind after they pass, and everybody goes ooh and ah, and they look up at it, and then you can sometimes still see the little trail left behind. And that's because of the ablation. As the material was vaporized, it created an ion trail, an ionized trail in its wake. And then the upper atmosphere will kind of move and dissipate, and you'll see it kind of as a wispy, hazy snake kind of disappear over time. And then there's different kinds of meteorites. Once they make them down to the ground, if they can survive the trip, you have stony meteorites, which have multiple types. Iron meteorites, which are composed mostly of your iron and nickel, typically. And then stony iron meteorites. And if I were to speak briefly on iron and stony iron meteorites, they have a really, really high metal content, and oftentimes a crystal structure that's formed in them if they cooled really slowly in outer space, called the Widmanstatten pattern. And I'll show you guys if I can. I actually have my wedding band has that pattern on it. Hopefully it comes up in the camera later. But what's interesting about iron and stony iron meteorites is they're believed to have formed in the core or around the mantle of these giant asteroids in our early solar system. And because if they were large enough to have their own gravity and those metals were able to condense and fall towards the center, basically creating little planetismals or little baby planets. But it was a violent early history to our solar system, and many of them may have suffered major collisions. And if that collision exploded that asteroid or destroyed that asteroid, then all of its guts would have been thrown out into space, including some of the high metal content that would have already made it to that asteroid's core. So when you are picking up an iron meteorite, you're actually holding up maybe a small piece of the heart or the core of an ancient asteroid. And then one term that's you'll see all the time when you're looking at meteor showers or trying to look up online where to look and at what time to look at nighttime. And usually past local midnight is the best time to observe meteor showers, because you're on spaceship Earth traveling through our solar system, and as the Earth is traveling through this debris field, past midnight is when you have the best perspective of the Earth passing through that field. And much like you driving down a road and encounter, trees or objects on the side of the road, and you see them whizzing past you in all different directions, it's kind of like what you see here in this image. You see all these little meteors moving in all different directions, but that's just a matter of perspective. But you're actually moving, the Earth is moving towards that direction, and that's why the meteors appear to originate from that area in the sky. So if they say the Perseid meteor shower, all of those meteors will, if you were to draw a line on them, will originate somewhere based on our perspective from the constellation of Perseus. And that's where we get all these different names of all of these meteor showers. But then every once in a while, you'll have little sporadic meteors that are going perpendicular or in an opposite direction as to the rest of the meteors in a shower. And those ones are usually outliers and sometimes a little bit more random or coming from a completely different object, maybe not related to that actual meteor shower. And then I went ahead and I looked at some of the meteor showers that we're going to have for the rest of this year.
So Seth, can I jump in with a question here?
Oh yeah, sure.
And I'm gonna make sure I get the word right. The biggest meteorite found on Earth. Do you know about that? And are they the biggest ones typically made of iron or ore?
I do not know which one is the biggest. I don't know. Maybe Paul might know. But if it's fairly large, it probably is composed of a large majority of iron and nickel. But Paul, do you know maybe
Oh,
which
I'm trying
one's
to
the
think.
biggest
When we
one?
were at the American Museum of Natural History back in New York, they have a huge one there. I don't think that's the biggest. Um, at the planetarium, we have half of what was probably the largest meteorite that we know of to have fallen in Nevada. And you can see that Wittgenstein pattern, that really interesting one that it'll be fun for Seth to hold that up. But so we do have a huge one, and it's an iron nickel one. And those tend to less ablation occurs. I mean, it's harder. They survive a little bit better than I think the Stony ones tend to break up more often, if that's correct, Seth. But anyway, so that's a big one, but that's a good question. I'm sure you could Google it and be fun to go check
Now
it out somewhere.
the one at the American Museum of Natural History, when you say huge, what are we talking?
Oh, I'm trying to think back to it, like a small car, kind of. So
Yeah, that one's
it's
big.
That's pretty
big.
big. All right, that's
Yeah,
really huge.
yeah,
That'll leave a little sizable dent on the ground.
yeah, yeah.
And then an interesting thing to know actually about meteorites, if you're extremely lucky enough to encounter a meteorite that is freshly deposited and you actually see it hit the ground,
Mm.
despite what you would think about it being really hot because of that process of ablation that just occurred as it braked through our atmosphere, it's actually freezing cold. And oftentimes you have to wait before you pick it up or touch it. Otherwise you'll get freezer burned, because one, it was large enough to make the trip, and only the surface, only the outer surface of it was maybe affected from that ablation process. But it also spent billions of years floating around in space with almost no temperature, and it's spent most of its time in freezing cold temperatures and only a fraction of a moment in extreme temperatures. It would be akin to flash cooking a turkey in the oven, and only, like burning like the outside of it, like a super super hot oven, but the inside is still ice frozen. So it would be kind of, comparable to that, where it's only a fraction of a moment that it's has those intense pressures and temperatures, but the inside is still super cold. So when it hits the ground, if you're lucky enough to find one that's fresh, you want to wait to pick it up because you'll probably get freezer burn. So let it adjust to air temperature. But I put together this little table for you guys here, touching on some of the meteor showers that we'll have here for the remainder of the year. Now, there are tons of meteor showers, and only several of them are the more popular ones that people know about. But generally, even that list gets cut down even more per year because of light pollution from our moon. So what I did for you guys in this table is I only included the meteor showers that are a little bit more worthy of noting, that are from this point on to the rest of the year where the moon is less than 50% full. Because any more than that, then the light of the moon starts to swallow up some of your good observations of little meteors that you might otherwise miss. And as you can see down below, I mentioned before that the best time to observe them is after local midnight, but some meteor showers are still good, in the late hours, like 9 or 10 o'clock. You can sometimes catch some really good ones. And then just to kind of wrap up and just finish off a little bit, during our solar system's formation, all of the comets that are still even out there in our solar system are thought to have brought all the water to all of the planets in our solar system because of how much water they actually have. You got to remember, even though that the Earth has a really, really big oceans, compared to the rest of the Earth, it's just a very thin film when you compare it to the rest of the Earth. So it's believed that a lot of our water, if not most of it, came from comets. And even up to today, it's estimated that over 100 tons of debris still fall to Earth every single day. And most of that is still in the form of little teeny dust grains or ones the size of marbles, or when you get meteor showers and you get to see some of them that are cool enough to actually put on a display. And I did some of the math and kind of did the average density of an average meteorite and kind of extrapolated some information out of that 100 tons. If you were to add all of that up every single day, instead of all these individual microscopic little invaders, and if you were to add it all up into one object, it would be about equal to a 3.2 meter asteroid every day, which would be quite disastrous, or especially if it went over like a popular or a populous, you know, center or area. But if you added up all the material in a year, it would be an object about 22 meters wide, which would be about as far as most people can throw. And it's just quite a large object. And then it's been found that a lot of organic compounds and amino acids that sometimes are, you know, are the same compounds that we find in our own DNA and RNA can be found in comets and meteorites. So it's kind of a good thing to kind of sit back and reflect that when you're floating around here on spaceship Earth, not only are you born on this Earth and you're made up of the atoms that are here on this Earth, but you actually draw some of your origins to the sky up above you too. So yeah, that just about wraps that up. And if you guys want to see,
Oh, that's pretty wild, Seth.
I'm gonna
Do you
stop
have
the
your
video share.
ring
Yeah, I
there
got a
and-
couple of meteorites for you guys. I don't
Ooh.
know how well you can see these, but I've got two little ones here. One of them is a little bit more iron based and one's more iron and nickel. And you know, they're quite heavy, as they typically will be, especially if they're heavy in iron, because that's what they're made of. But a rocky meteorite might just feel like any other rock you might find on the ground. So usually if you think you have a meteorite, usually you want to go get it tested somewhere just to confirm. And I don't know, it's probably going to be really hard because the camera, but I have if it focuses in here.
Doesn't want to
Yeah.
focus on the pattern, unfortunately.
Focus.
Yeah.
But there's a bunch of diagonal patterns that begin to form in the Widmanstatten pattern because the iron in these ancient meteors or asteroids condensed and cooled over very long periods of time and was in zero gravity. Molten iron will actually start to develop a crystalline structure, a little matrix. And if that material makes it down to the ground and we were to cut it with a blade and polish it with an acid, you can actually begin to expose that pattern, and it's quite extraordinary. But it won't form naturally here on Earth because that iron in similar processes would cool too rapidly for those patterns to form, or not only too rapidly, but also we have gravity here, so you wouldn't be able to see them that way either.
Very neat.
And then let me see if I can pull up, just to wrap that up real quick, that little meteor shower page I was telling you guys about. So let me try doing one last little screen share here, just to kind of show you guys what the debris field looks like when Earth passes through. So here's a website called meteorshowers.org. And if you were to go here, you can actually kind of see what these debris fields look like if the Earth were to pass through these old trails left by comets. And this blue line here would be the Earth's orbit. And as the Earth orbits throughout the year, sometimes it passes through those fields, and it'll pass at the same time from one year to the next, which is why the meteor showers that we encounter on our calendar are very predictable and occur at the same time every year.
Is that like the bugs on my windshield then when I'm driving
Yeah.
through certain areas? Cool. Thanks, Seth, for the
Yeah, no problem.
incredible details on that. Hey, I was just going to say, Chris, I think I sent my link over to Tim, and I see my name listed twice because I think he may have used my link to join in. But
Yeah, it looks like
all
a picture of a
Mcfarlane's
lion.
now.
yeah, and he's much more handsome than I am. It looks like a great mane that way, and that kind of represents one of Tim's favorite creatures, the lion, but also the Leo constellation. We were looking at a double star in that one. Algebra, is that right? Or Algebra? I think Tim. Yeah, Tim was checking on the pronunciation based on the Arabic, and that's a star that's in Leo, the lion's mane, and that's the radiant for the Leonid meteor shower as well. So if you're interested in looking, there's some cool stuff like those Leo triplets in the galaxies that you can see in Leo. Is one of the things that you might want to take a peek at during this time of the year before Leo starts dipping below the horizon. Or if you stay up late, like Seth was talking about after midnight, we got Jupiter and Saturn coming back, right?
Yeah.
So chance to see maybe the great red spot on Jupiter or some of the moons, the Galilean moons that Galileo saw through his telescope and was able to track those moons, Europa and Io and Callisto, some of the others. That way you can check that out. Or the rings of Saturn is always, I think, probably one of our favorites for most people. So some good things to see if you're willing to stay up a little bit late, or if you can't stay up that late, there's lots of good things you can still see to other double stars and clusters.
Are you guys willing to field a couple questions before we send
If people are willing to stick around, we're glad to. Yeah, if they're still wanting to ask a couple. Looks like there is one question, I guess, that came in.
You there. Kevin is asking, related to your meteors, how can you tell if the amino acids / organic compounds were in the meteorite or came from the Earth where it landed?
Now, I'm not by any means an expert on this. I was just gathering some material, but sometimes you can find organic compounds in the meteorites themselves when you cut them open and go into some of those crystals and check out what's present inside those the matrix that might be there. But I believe there was the Stardust space mission that flew through a comet tail, and that comet tail was able to detect some glycine compounds inside some of that dust it passed through. So that definitely wasn't on Earth when it detected those compounds.
That's a cool mission.
I don't know. Do you have other insight into that question, Paul?
I think that Stardust mission, like you said, it was an interesting, a little panel came out from the spacecraft, almost like a tennis racket, and caught those materials in an aerogel, a really interesting material. And then it was sealed up and landed on Earth with the parachute and everything. And they were able to open it in the lab. And like Seth said, at that point, when they were able to open it up and look at those pristine materials, those were particular amino acids that they could for sure identify different compounds. So that was, you can go and look at the research and the results of that particular mission. And then they're looking to return some material from some asteroids and comets to continue to study those things. And then of course, in greater concentrations on other planetary bodies, you can use a spectrometer or a spectroscope to look at what kinds of chemical compositions exist out there without having to bring them back here. But that's a good question. Yeah, as far as cutting open a meteorite or detecting things inside of it, be interesting to read up on that or look into that a little bit more. So yeah, I can't add too much more. I don't know if Tim, do you want to?
I can add, first of all, do I sound okay?
Yeah.
Yes, we can hear you, yeah.
Okay. There is a meteor that I think landed in Australia that I was reading about that had a variety of amino acids and amino acid-like substances in it. And these molecules are simple enough that they can, arise without a lot of things that are happening. And glycine, which you mentioned, is the simplest amino acid chemically. Separating, what came from the environment and came from, the meteor is tough, but scientists are pretty sure they have found amino acids in at least one meteorite, and enough that there's some papers on it.
Cool.
So is the thought that possibly some early forms of DNA and RNA came from were brought to Earth from these meteorites?
I have never seen any research to suggest that.
That was the theory that was put out there. I don't know how much substantiation of that is that's the case, but it's an interesting concept to explore for sure. So there was even some, I know recently there was a scientist that had proposed that perhaps we have some Martian meteorites, rocks that were blasted off of Mars and eventually found their way through our atmosphere and landed on Earth. And some people were positing whether that perhaps the basic materials of life came from Mars, which would make us all Martians, which would be kind of interesting if that played a role chemically or organically in the process. Again, we don't have substantiation of that at this point, but it's certainly an interesting question to pursue. Yeah.
Oh, and then
really
chemistry is out there. These chemicals and elements are.
Mars.
We
Paul,
got
you
one.
mentioning Mars there briefly. I was gonna add that meteorites don't just have to come from comets or from asteroids leaving a debris field. There's debris left around floating out there from impacts that have actually hit some of the other planets like Earth or Moon or even Mars itself.
Mercury, we think we may have some.
And Mercury, yeah. And some of that debris ejected from those massive impacts has even made it to Earth as well, which is how in at least one form we're able to have a sample of the planets without actually having a sample return
mission. Yeah.
And the reason we can identify them is just by chemical makeup as being similar to the makeup of the planet itself. So
yeah, Tim was pointing out the other night when we were cooking up our comet, the different chemical compounds and things that we didn't include. What was that? The cyanide?
Cyanide.
Trace amounts of different things. We thought probably for a classroom demo, it's not material that we would want to simulate that way. So. But yeah, so interesting stuff, cool objects, and the search for different types of chemistry out there. We haven't found life yet, but that doesn't mean that it isn't necessarily out there. So
let's end with a Black Rock specific question we have here.
Okay.
All
And
right.
we'll wrap things up because I think we could talk about this search for life for another couple hours at least.
Or days.
Yeah, exobiology is fun.
So Margie's wondering, do you know if any meteors have fallen in the Black Rock Desert area?
You know, I'm sure there probably has to have been. There was a show called Meteorite Man where they used to come through different places, including Nevada, and they found objects. And I think you can watch that on YouTube, the episode where they came through Nevada, but I'll bet there's a very good chance. You find them in deserts and in other, like Antarctica is a great place to locate. That's where they found one of the Martian meteorites that they thought had little indications that some people interpreted it as being produced by living life forms, but most scientists didn't agree with that explanation. But I'll bet. Have you heard of any in particular, Seth, that were found in the Black Rock Desert?
Any specific ones? No, but I do know that the Black Rock or big polar regions like Antarctica or even the Arctic, because sometimes those ice shelves are very fresh and very new. Any small meteorite, even one as big as this guy, sticks out like a sore thumb against a white backdrop, or in the case of the playa sometimes. I'm not saying that. Oh, go ahead.
Goodness gracious, the Black Rock Desert is one of the best places to hunt for meteorites.
Right, and
I know
not every rock though is a meteorite.
Right, but the thing is, if you find a black rock on a white playa, that's miles from any other structure, unless it got moved there by a vehicle or something like that, your chances are pretty good that might be a meteorite. And I know that your predecessor, Paul, used to go out, and talk about people going out there and hunting meteorites. So, I'm sure it's been picked over pretty good. At the same time, that's an area the size of a small state.
Yeah.
It's worth investigating further.
No, for sure, and it's interesting because, of course, at the Keck collection, they have some that are on loan also at the planetarium that were found here in Nevada. That really big one was found outside of Tonopah. There's a book that was at a Sundance bookstore that I was looking at before the coronavirus thing, and it was about a guy that collected very small micro meteorites, and he found ones on basically he would gather dust and material off of his roof and other surfaces, even within his, because Seth was talking about this material comes through the atmosphere all the time, every day we have material. And so if you can put it under a telescope and use a spectrometer, you could actually identify these particular components that have the right composition. So for sure you could find, I'm sure, good objects out there. It'd be a fun thing to do.
Yeah, that book is just being published.
Yes. Yeah.
Yeah, and he was offering for a while if you bought the book through a certain channel, you got a sample.
Yeah, yeah. So you could have your own little mini museum of micrometeorites and things like that, which is a pretty cool concept. So, yeah.
All right. Next in-person rendezvous, we'll have a meteorite hike.
There you go. There you go.
Fun.
Yeah, yeah. Reno Gem and
Absolutely.
Mineral Society, I'll bet, could take you on some fun walks. Some of those folks as well. So partner up, different groups, and do some exploring.
Yeah. All right. Let's close this thing up. Just thank you so much, Seth and Paul, and a little bit of Tim there in the end. Yeah. It's really fun having you guys. Anytime we get folks who are just so passionate and knowledgeable about any subject, it's really fun to listen to. So thank you.
You bet. Thank you for letting us join you. And I hope people will think about whether it's a telescope or joining us for the Astronomy Club and getting to use some cool stuff and do some fun discovery.
Yeah, good point.
And thank you to all of our viewers and listeners there.
Anyone who's listening, go and get a membership for the Fleischmann Planetarium. Sign up for it. It comes with some fun perks, but you also get to support people who are teaching us about really cool things. So go do that. And then after you've done that, become a member for Friends of Nevada Wilderness and Friends of Black Rock and Nevada Outdoor School. And then that should take care of your charitable giving for the month.
Good advice. Yeah. Thanks, Chris.
Thanks so much, guys. I'm going to end this. Have a great night. Bye, everybody.
All right. See
Good
you
night.
guys.
Bye.